Welcome students. So today we are going to see the first order logic form, that the short form is FOL. So the proportional logic treats every statement as a whole without understanding its internal structure. This makes it is the different or difficult to represent the real world knowledge. The first order logical introduce the variables, predicates and qualifiers, enabling us to express the statements about group of objects and their relationship. This makes it is more powerful and suitable for artificial intelligence applications. Let us now understand the syntax of first order logic. So the first order logic, we can use the functions and the predicates. This function, it should be written as a function followed by the terms inside the brackets, like function of term 1, term 2 and so on. Similarly, a predicate represents a property of relationship and it is written as a predicate of term 1 and term 2 and so on. So this is the basic representation of the first order logical. So now we are going to discuss like the how the structure is representing. So the proportional logic, we can use the simple form of true and false form. Okay, so these two is like how that can be represent means, for example, it is raining. So this it is raining form, sometimes it will be called as a functions of the level. So this proportional logic, it may consider like the simple examples that cannot express the more complex statements. Some humans are intelligent, of all mangoes are sweet. Okay, so the generally proportional logic, it will be focus on the true and false statement. For example, it is raining, it is not or may not raining, like that. Okay, but in the first order logic, we can use with the sum and all. So this is the proper example for related to the other context. And this first order logic, it will be with the overcome the some other expressions like the sum and all. It should be obtained of the relevant to the construct. So already we were discussed in the before the thing. So this FOL, it will be just focusing like the object. It could be related to the entities, and relations, it could be connected to the object, and functions, it could be mapped or connected to the object. So in this thing, so we have to understand the predicate logic of the functions over here. And the next one, the first order logic, like the proper example here. So this is the proper example of this. So consider the sentence, X is the girl, and here the X is the subject, and the this X is the girl, it is the predicate. The first order logic, it should be the representing the girl of X and written as a girl of X. So X, it could be just connected to the girl. So this shows how the natural language can be converted into the formal language expressions. This is the sample syntax of function. Always we can call it as a term 1, term 2, the n number of term 1, and the predicate also, it will be like called like the term 1 and n number of the expressions. So this is the sample structure for using the thing. So always we can call it as a, this is the subject and this is the predicate, and this is the quantifier. So quantifier, we are having the some structure and some statement in before solving the FOL method. So we are having the two type of the quantifiers. The first one, universal quantifier. The second one is the existential quantifier. So the universal quantifier, we can make like the for all as the simple. So the existential quantifier, we can make like the there exist of the thing. So that we can call the for all, we can call it as a for all, and the there exist, we can call it as a for some. So all employees, this is we can make like the all, that is a for all symbol. X, the employee, it will be stored as a X as the variable here. So always we can call it as a employee of X. X, it will be as a hiding technique. It related to the variable. And some students, we are having the there exist the student of X. But here having the sum, we can call it as a for sum, but student it will be just store as a variable of X. So this is the basic element of structure of making the LOL statement. So here we are having the different kind of the leaf nodes, like a leaf node and then that label names, etc. Based upon the label name only we can make like the connecting the structures and statement. For example, the constant, always the constant we can talk about like one number wise and then character wise and then name wise and then location wise we can call it as a constant. And variable we can call it as a x, y, z, a, b, c, like that. And predicates we can call it as a we can store as a one of the variable over here. One statement is there, that statement it could be just stored into the some of the variable or some of the numbers. For example, the greater 5 comma 3, the student boy comma girl. So student it can be represent like the boys and girls, and greater it can be represent like the 5 and 3, that is a numbering function. And the function the mother of Zan and the color of basket. So this is the basic function over here. And then these are all the connectivity for all there exist, and then that is a connected symbol, imply symbol, like that. And then equality, this is the equal number. And then the quantifier we can make like the for all, and then there exist. So this is the basic structure of the FOL, that is a first order logical function. Thank you.